We're going to spend time today talking about two things. Okay, the design process in engineering, and then conditional statements. Remember conditional statements from 10th grade geometry was like if then. If this, then this. If this, then this. If you didn't go over that in geometry because someone didn't have me, don't worry about it for now. We're going to go over what that means. Now, we're going to talk about that. We're going to talk about design and then the conditional statements. We're going to look at three items. We're going to look at a gum package, so a package from an actual gum, so the Trident. We're going to look at an electric toothbrush and study how that works. And then third, what we're going to look at is this new eye reading software. Sharpen down because I'm going to keep talking for a while. Hold the base steady. It helps. Okay. Now, the first thing I want to look at is a gum package. And I know this sounds crazy, but maybe like 2 weeks ago, I tried a new gum. Has anyone had Trident layers?
Yeah.
Okay.
I would have been paid.
Forget the gum taste, guys. We're not talking about the gum taste. Now, the cool part about this, and many of you have noticed already, okay? If you look at it from the side, from a profile, okay, it looks like there's almost two sections of the package. Does everybody see that? There's a section here and here. Now, the thing that I found to be completely just mind-blowing was that, like, okay, you open the package, it drops down, and you see that there's two different slots, right? Now, what do you normally do? Who noticed when you finish this layer, what do you do with it?
Rip it off.
It rips right off, right? And some people didn't even realize that. When it rips right off, what happens is this. The actual package turns into one package now. So you have like this, you have this two-layer package. So whenever I see Trident layers, I know everybody thinks about the layers of gum. I was thinking about the layers of the package. Because right, there's two layers right now, two compartments. So you take it off, you finish it, and they put a little perforation here. And then when you rip the perforation, if you do it correctly, like Mr. Howell doesn't always do, and you close it, now it looks like one layer. And most people don't even notice that. I know, right away, I didn't notice the first time I had it.
I did.
Mr. Howell was born.
What you notice now, okay, again, this fits exactly there. Now, with this layer here that's attached, when it's attached, the slot still fits in. So here, this closes right in there. What do they do when they take it off? They just put another slot there. And now this slot closes up, and now you have one layer. Okay? Is that clear what the idea is so far? Now, here's what we want to do. We want to today talk about the ideas and the different possible ideas. Get off the screen, come on. Thank you. We want to talk about the ideas that go into making this. And there's a lot that goes into it. So I want to hear your opinions and what you think. Again, right away, the design process. What goes into the thought process behind this? Size. Okay, so right away, let's start with dimensions. Okay, this is the stuff that I want you to be writing here, okay? Dimensions. What else? Materials. And we'll expand on all these. We'll expand on all of them, please. So these are the main categories. Start. Symmetry, good. So design or dimensions. I'm going to leave it for now because we're going to expand. So let's just draw a little arrow. We'll say symmetry.
Right on the paper, right?
Okay. We're going to branch off each of these. So if you want to put like even, you know what, to make it easier, make a table. If you want to make a table on your paper, okay, it doesn't matter using pencil, just erase it, please. Go ahead and type, just put in the table headings, dimensions, as the first thing. Second thing was material. What else do you consider when you make a package for gum?
Surface area.
But that's material. Structure comes about from the dimensions and the material. That's what we're talking about. Surface area is a function of the dimensions still. I want headings, guys. We'll talk about subcategories in a minute.
Design.
So aesthetics? Aesthetics? Is that what you're talking about?
Give me a dictionary.
Aesthetics is like the way it looks and the colors, okay? Weight comes from what though? Material and dimensions, both. It's a function of both. Very good.
The way it works.
Is that AES?
AESTHETICS, aesthetics. Yeah, if you're looking at the weight, you said weight?
No. How like it's designed to fold into.
Oh, that's absolutely right.
Compatibility.
I would say
That's more like material.
I would say it's a combination of aesthetics, believe it or not, and dimensions. The dimensions will make it fit. The aesthetics, like that little cut, that's also something there. So we could say features.
That's the same thing.
What about commercial?
Yeah, but aesthetics is really the way it looks, whereas this goes to how it actually works. Okay? So we're looking at the features of it. Those are four main categories. There's one more that nobody ever considers. And you're probably not going to even think about it.
Extra price, the cost of making it.
Not advertisement, but the cost. The cost. Very good, Karen. The cost of making it.
Just put like a money.
Now,
Yeah.
here's the thing. The material is not the only cost. The overhead to actually make it, the machines needed to make it, these all go into cost. So cost needs its own category. Sure, the material will affect the cost. The dimensions will affect the cost. But the cost is really its own category. Because depending on the design of it, it's going to cost more or less. Okay, so if you're in a manufacturing technique or a manufacturing plant, and you're trying to figure out how much this will cost, you need to look at the assembly line process that goes into making it. Okay, how many people does it take? How many machines does it take? What kind of machines does it take? Those all go into cost. So, under each of these, let's go through them and go through each analysis. First, material. What does the material affect? So the material is a cause. Raise your hand, please. The material is a cause. What are the effects of the material? Give me one of them. The weight. Very good. Now I'm going to put, believe it or not, what I'm going to do here is this. I'm going to put weight like this because it's really both dimensions and material. Okay, it's going to show up in both categories. The weight comes about from the material. If you have metal, it's heavier, right? And also the dimension, the size. So the weight's in both categories. So I'm going to write it like that.
Doesn't size have its different, it's different than weight?
Size is dimensions. Size is dimensions. Again, weight is a function of...
No, I know.
Weight always comes about from the density of the object and the size of the object. So you're talking about the dimensions, and the material is the density. So that's what you're looking at there. Julian?
The area.
The area.
Surface area.
Okay, that's a result of the dimensions. Thank you. Not the material, though. We're looking at material first. Material.
Oh. Preservation?
Good. How the gum holds. So the preservation. So if, for example, when you put salt into stuff, why do you salt meat? To preserve the meat. That's why you do it. It's not just to put salt in it. It keeps meat for longer. Why is a milk container not translucent? You notice when you go to Giant, it's translucent. You can see into the milk. Ever go and get a half gallon of milk at some stores and they're opaque? Light can't go in. Light actually affects the milk. More light that's exposed to milk, the less its length is of light. So you could actually, your milk will expire faster if it's in a clear bottle, even though everybody still uses clear bottles. But a lot of bottles now are changing when they're solid and light can't get into them. Okay? So we say the preservation, let's use that word, very good. What else? Portability is crossover. Let me get hers, her hand was up, no? Good. So we'll say structural integrity. Okay? I know it sounds crazy, but let's, for dimensions and material, it's a crossover. Structural integrity. And let me explain this. Your gum package might weigh very little, but it might rip into pieces, right? And that's not a good package. This one is very good. It doesn't rip apart unless I want it to rip apart. So the structural integrity is a function of its dimensions. Will it stay together based on the dimensions? And the material. Is it a material that holds well? Okay, what was the thing you said that I didn't write yet? Portability. And portability is actually both again, though. Portability is a crossover again. Okay, portability is a crossover. Because if it's too big of a package, you don't want to carry it in your pocket, right? So it's not portable. But if the material is something like metal, you don't want to carry that in your pocket either, maybe, because it's really heavy. So the portability is a crossover. Let's go to aesthetics for a minute. Color.
Oh, that's special.
So aesthetics, color, good. Texture,
Shape.
Shape is dimensions.
Yeah, I know, but I mean like.
No? Try it. It's not a crossover. Aesthetics have nothing to do with the actual shape. It's how it looks. The shape is then, another thing that applies that, but it's really under here. Shape.
You still under aesthetics?
Still aesthetics.
That's how it looks, right?
How it looks.
Texture would it be both?
Appeal.
Sure, you're right. Texture would be both. Yep. Texture would be both of these also. You're right. Absolutely. Thank you, Bridget. Julian?
I was going to say pictures.
Pictures or appeal. I like the word appeal. Somebody said that. Very good. I heard you. That's why I'm referencing you. Yeah, the appeal, aesthetics. I mean, come on, nowadays every gum package has all these fancy images on it. It's flowing. It's got all this stuff. I mean, it's appeal.
I do.
Kenny, you wouldn't believe how many people make decisions based on appearance.
Oh, I do.
Okay?
I like
Whether you know it or not, you do it all the time. You do.
Not for gum bag. I mean, like.
Okay, but think about a computer. We're going to see how this...
I know, but we're talking about gum packaging.
I understand, guys.
I understand that.
We're going to take this and try to apply it or generalize it. So we're trying to think about it on a lower level. It does appeal. It does have some sort of appeal. Whether you care or not is up to you, but it does have appeal. Karen.
Can you go to features and like a little split?
Good. So the first thing is the cut in the package, or we can call this the slit.
Where you tear. Where you tear.
Hold on.
So
get
what
them
you
all,
just
Karen, I
say,
got it. Hold on.
abilities?
That's what you do in engineering, guys. So here, everybody see this little slit right here, where the gum can close into? It was on this one also, wasn't it? It closed on here. It has more than one here. So the cut or the slit in there, that's a feature of it. Karen mentioned something else, but I want to see if someone else can get it first.
So the double package.
The double package, sure. So the fact that it's layers,
But isn't that it?
okay? Double meaning. The symmetry affects that, sure. That can go under layers, yeah.
Like the fold kind of thing where you can actually close it.
Okay, the fold itself.
Like where you can like put the.
So the fact that the fold actually meets up. So the fact that when it folds up, it actually does still fit and it does still look like a pack of gum now.
Back to the
Okay.
Not that, but like I was saying, like how you can like open it like a little flip kind of thing, but like you can close it into a little hole or something.
And close in here, okay, so that's the fold of stuff. Give me something else, other stuff. There's one big thing that, you said it already, but I want others to hear it. Or tell others to try it. The whole rib part, what do you call this? What's the word though? Perforation.
I know what it's called.
Okay, the fact that you have all these little cuts in it already, it makes it easier to rip off, that's a perforation. Okay, it's a perforation. What does the cost have under its
Well,
column?
making it.
Everything.
A lot of different things, okay? Okay, taxes, but we're talking about, guys, we're not talking about cost like cost of the consumer, cost that goes into making it. Cost that goes time, manufacturing techniques,
Is it
Products.
so time it takes, manufacturing techniques, whether it's machines or humans, right? Humans cost more than machines, obviously, you have to pay a human, whereas a machine, you have to pay the electric bill. Your electric bill is less than humans usually. Stop. Not funny. Julian?
Oh, no.
Okay, there you have. What else goes into cost, guys? What else?
Materials actually.
So materials and costs are linked that way, good.
Transportation.
Link that's good, you're right. How do you transport it? For example, when they make one of these, it doesn't come in one pack. They package these in packages like 24. Then they distribute those to like, supermarkets or delis or Costco or whatever corner store. Okay? Because my dad buys the packages of many of these at the delis. So the packaging, packaging costs, and I'm talking globally, not packaging for one package, but for several packages here. Okay? Employers goes into manufacturing techniques still, because we said human versus machine. Okay, import, export in these other countries, but that's still going to go under packaging costs. So let's just say transportation.
Isn't that what you put as material?
What do you mean by taxes, though? Specify. Some of you guys said taxes. What does that mean?
It's not a tax. Exporting goods.
Okay, taxes like that, sure, but not tax on the consumer. That's not going into cost, though. So taxes on transportation. So if in parentheses you want to put taxes, that's fine.
Advertisement.
Okay, fees. Advertising, very good.
What do I gotta do?
You have to advertise, guys. You also use commercials.
But when's the last time you seen it?
Especially the layers, like you can pay
That's
the
a
layers.
different thing. We're talking about the gum package itself, but usually your markup will go in, but for now I'm going to leave it. Because I want the cost that goes in the manufacturing itself. Okay? Alright, now. This is one example, guys. This is the first example. Now, what I want you to write at the top is this. This is the design process. In engineering, here's what you do. You go ahead and you say, all right, well, let's take a look. I want this gum package to be portable, right? So portability affects its material and dimensions. But I want it to be material that can, not rip in half. So then suddenly you're saying, okay, that it's going to be a durability or a lighter material. But at the same time, I don't want it to cost a lot. Well, maybe this material does cost a lot because these gum packages do cost a good amount now. This is like $1.50 or $2 to buy this. You go on to like 7-Eleven, it's like $2.50 now. Okay? Granted, you are getting 14 pieces. Old Trident used to only get like 10 pieces. You're getting more, but the cost goes into it. So what are you constantly doing?
But that's 10 cents a piece.
Well, the Costco actually.
Guys, answer the question. Come on. What are you constantly doing here with all these different things? Byron, thank you for raising your hand.
Aren't you trying to find like the cheapest thing to buy Isn't it supply and demand basically?
It's supply and demand, but in this case, not supply and demand, but it's called optimization.
Oh,
Now,
that's exactly what I
what
said.
you're doing,
Exactly what I said.
listen,
Son of a gun.
what you're doing here is the following.
Strength, that's
Yeah.
right.
You're taking several different constraints that you have. So for example,
Here we go.
you might have a constraint of material. You might have a constraint of cost, a constraint of structural integrity, portability. So for example, here's what your boss tells you. Your boss tells you several things. He says, I want it to be able to hold 14 pieces of gum, to sell under $2, to be able to ship internationally, to be able to rip off and look good. So we rip off the package. To be able, no, not rip off people, rip off the package. Sorry. To be able to have a good texture, like, believe it or not, this sounds weird, but this has a different texture than any package I've ever
Is it like a
felt.
water
It really does. It's something different.
Is it like a liquid water?
It's not like, it's not like a cheap foil that comes off and the foil just unravels. It's something that's actually, nice. Okay? It's like a glossy outside, or you want to, well, it's not laminated, but similar to that. It's a glossy outside. Okay? So, when you do this, here's what you're really doing. What do you call this when I'm doing this? What am I doing? I'm balancing. So, if you're an engineer that, is successful, you're somebody who can balance all these things and optimize what you need. So you have some constraints or limitations you have to stay within, and you have to balance it. So that's the whole idea of what engineering is. Whether it's mechanical, electrical, computer, all the fields, it's all about optimization. You want to make the best of what you've got. Just like in high school, guys, when somebody says to you, go home and make good use of your time, what are you doing? You're optimizing. When I go home, literally, guys, I'm not joking, here's my list of things that I have to do right now for today. I want to go home and make sure I cover all this stuff. So I need to do, during the day, I want to get this done. I'm trying to figure out at night tonight which one of these I want to pull into this category. I want to start doing some stuff with physics. We're going to possibly go to Six Flags. That's on my radar to do. I'm going to do something for math to use the movie Moneyball in the next future. But I'm taking all the things I have to do, and I'm finding a way to optimize how I can do it, in an efficient manner. So that's what engineering is all about.
You write it down all the time.
Right? And there's a physics that I have there, yeah. So we'll talk about that later, guys. So again, I'm thinking in my mind, I need to get these many things done tonight. How can I do it efficiently? So yesterday, I remember when I was here, I was very busy. Second period, I had like 7 things on the list to do. Sixth period, on my period off, I had like 10 things on the list to do. After school, even after the faculty meeting, if you came by, you saw I was recording a lecture for SAT. So I'm always doing different things. I'm optimizing my time. And some people are like, all right, well, how are you able to get through all these things? Well, you have to make sure that you have done them in the right manner. Some of you have realized that already. Some of you are really good organizers, and I noticed already that you use real good use of your time. Others, not so much. Others, I have to constantly say to you, guys, what are you doing in the hallway? I know you need a 10-minute break after school, but it's 5 to 4. Get some work done. Please, come in, do some work. That's why I'm telling you this stuff. You're not making use of your resources. It's all about resources, okay? If we had all the time in the world, would it matter? No. But we have 24 hours in a day. It's not changing anytime soon, so get used to it. Okay? This is an example of the design process. Let's go to number 2. Number 2 was an electric toothbrush.
With items that keep each other
All right. Now, before we get started, I'm not looking at the design process for this one. Now I want to look at conditional statements. And here's what I need. Listen to the scenario. So I get up in the morning, I go to use my electric toothbrush. Okay? On my electric toothbrush, it has a timer on it. And here's how it works. After 30 seconds of brushing, it buzzes once. So at 30 seconds, at time equals 30 seconds, it buzzes one time. Okay, it goes, zzz, and then it not buzz like in the sense that it buzzes or electrocutes you, but it stops and vibrates to show you that you're 30 seconds have gone by. After a minute, it buzzes again. You're supposed to keep 2 minutes a day, 2 minutes every time you do it, by the way. That's the time you should do it. I do 2 minutes every day, morning and night. Now, okay guys, these are good ideas, but let's continue, please. Focus. It buzzes once again after 90 seconds. Okay? So, every time it buzzes, 30 seconds have gone by. On the last buzz, it actually buzzes 6 times. It goes like zzz, 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 and you know you're done. That's what it means. Okay. Now, there's a lot more that goes on besides this, but generally speaking, we're going to start with this, and we're going to look more detailed. First, it's an if-then statement. If 30 seconds go by, what do? It buzzes once. Here's my if, here's my then. If 60 seconds go by, buzz again. If 90 seconds go by, buzz again. If 120 go by, buzz 6 times. Now, here's the question. I'm in the middle of doing my, brushing my teeth in the morning, and suddenly my phone rings, and it's Father John calling me saying like, Mr. Howell, you need to sub today, I'm just telling you ahead of time, or something like that, right? So my phone rings, and I see it's Father John, so I'm like, I gotta answer, I can't not answer. So I pause the toothbrush, right? So let's say, here's the scenario. I'm brushing, and 15 seconds go by. After 15 seconds, somebody calls. I hit the off button on the buzzer, or on the toothbrush. I turn it off, I answer my phone. I'm on the phone for 15 seconds at most with him, okay? He says, I need you to do this, no problem, we'll see you there. Okay, good. I turn it back on. What do you expect to happen? Raise your hand, raise your hand. What do you expect to happen? Adult. Reset. Kenneth.
Start at 16.
Start at what?
16 seconds.
At 16 seconds. 16. I saw other hands.
I said restart.
Restart.
I think it was start.
At what? From the beginning.
Oh,
I think it will
no,
start buzzing.
15.
Start buzzing, okay? Different answer. So start over, start from 16 seconds or pick up from where it left off, and then just buzz. That's what I've heard so far. You got something new?
Well, maybe subtract everything by 15 seconds.
Okay, possibly. Reduce everything by 15 because you got 15. Okay. Now,
I have a question. So it's programmed.
this is the program here, but we're saying that we have an interruption in the program.
So you stopped it or
Stop.
I literally hit, there's no pause on the thing. It's either on or off.
Oh,
It's gonna start over again.
Guys, the toothbrush, it either literally, if you hit it once, it starts to, vibrate and actually you brush your teeth. If you hit it again, it shuts it off. That's the
Oh
toothbrush.
yeah, so it's gonna
Okay.
start over again.
Start over.
You cleared it off.
Okay, so everybody would think that, and I would agree, I would think that. Now, in the actual thing, there's a little computer check. And here's what it says.
You tell that first.
Here's what it says.
15.
If it's been under a certain amount of time from your break, it'll pick up from where it left off. So, for example, if I'm brushing, I pause it, and I pause it, and I let it pause for 15 seconds, and then I go to brush again, it'll pick up from where it left off, because it keeps a memory lapse. Now, if I pause it, because pausing and shutting off are the same, and 2 minutes go by though, it resets. Because it's like somebody else is using the toothbrush and they're interchangeable heads. So like, I could take the head off of the toothbrush and then put another head on, somebody else could use it. So after 2 minutes, it resets. So what is this? It's an if statement. Here's what it is. It's embedded. It's called a loop. Okay, you've seen this. If you know computer engineering at all, or computer code, you've seen this. Here's what it says to you.
Because we know how to code.
Some of you have looked at this stuff. I know everybody has it. I'm just throwing it out there. It says, if pause is less than 15 seconds. If pause less than 15 seconds, resume. Again, so if I pause it, and under 15 seconds goes by, and I'm picking a number 15, it's arbitrary. Okay? If under 15 seconds goes by, we resume. You don't even need then anymore for computer coding here. Now, but also, what about, guys, what if 30 seconds go by? It'd probably still resume, right? Because it's only a short pause. So, let's agree on a number. Let's agree on a figure. So raise your hand. Tell me what you think the cutoff might be.
30 minutes.
Again, raise your hand. Kenneth. A minute. If you have a minute, you can put your hand down if you agree with him. Anybody different?
The number that's passed subtracted by 2 minutes.
The number that's passed?
Or the 2 minutes subtracted by 1 minute that's passed.
Okay, so he says 100, a minute 45 or whatever that would be. That's a function of another function. Very good. Keep that in mind.
I'll say 2 minutes.
2 minutes.
Brush equations.
5 minutes. I'm sorry?
How long is the
The cycle's 2 minutes always.
Oh, okay, well, yeah.
2 minutes. Okay. So, depending.
Attention.
Oh, no, it's gonna take a
The
minute.
freshmen have just been released from
Okay,
lunch.
Imagine, let's say, I'm gonna cut it down the middle and just say 1 minute, just to be safe here, okay? So if you pause for under 60 seconds, just resume where it left off. Now, if not, how do we write that in computer code? Anybody know this one? Has anyone ever seen this? Edgar, you come across this yet? This code for if not, how do you write other conditions? So what if it's more than 60 seconds? How do you write that in computer code? No? Okay. You write else if. One word. Else if means in any other condition. Or else. That's what this really means, but it's else if.
Can you write it?
So or else do this, okay? Else if, meaning do another command somewhere else. And so if you're doing Java or C++ or MATLAB or HTML, they're all different languages. So you have to learn to adapt. So this might not be the code for some. But for MATLAB, that's what you would use. Now, it says else if, and we could say start over, or we could say end. Else if end. Okay? So, here's what the toothbrush is doing, your computer inside it. It's saying, if you pause for under 60 seconds, resume where you picked up. If you pause anything more than 60 seconds, end the program, which means that the next person to hit it will start over the program. Okay? Again, these are things where you're going to see in engineering. So the first example, we did the design process with the gun. The second example is if-then statements. Now, what I want to do is put these together. What does the third thing say there? An iReader. What is an iReader? What do you think of when you think of iReader? Give me suggestions.
An Apple product.
An Apple product. Good.
I think of like when you go to the eye doctor and they put you on the
Okay, you go to the eye doctor, they look at your eyes. iReading, very good. What else?
I think about movies, when they like sit, they add it.
When they scan the retinas?
Oh,
Yep.
yeah.
When they scan the retinas in the thing like Mission Impossible and stuff. Okay, iReaders. So you guys get iReaders, right? Now let's watch a video on what iReaders really are. Okay, this is a new technology they're starting to use. It's really cool. You don't have to write anything for a minute. I'm going to pause the video again. So if anybody watches this later, I'm pausing so you.